Well, hello. This lesson we're going to talk about arc measures and lengths. Okay, so as you see, the main topics here are central angles, arcs into three types. You're going to learn what is an arc measure and what is arc length. And then I'm going to try to finalize this with a clarification between the differences between arc measure and arc length. So let's go ahead and get started. So first of all, what is central angle? Well, the central angle is an angle whose vertex is on the center of the circle. So, if you got the center somewhere around here, and you were to draw an angle like this, okay, so something like that, you've got a central angle right here, okay? This angle, we can call it like PQR or something like that. So, angle PQR is an example of a central angle. I could draw a couple other central angles if you wanted. So anything around here where the vertex touches the center of the circle is considered a central angle. Here's another one right there. So maybe this is PQS or something like that. An example where something is not a central angle would be if I had an angle where the vertex is not on the center. So something like that. We're going to learn about those later. Okay. This is a different type of angle, not a central angle. All right. So ignore that one. These are central angles. Okay? Now, what is an arc? So if you have a central angle, actually any kind of angle really, but when the angle crosses the parts of the circle, so for example, it's right here is a central angle. Okay, it creates an arc. An arc is just a part or a piece or a section, a portion, a fraction. I got a bunch of words there to emphasize. It's just a small piece of the circumference. So the circumference is all the way around the circle, and the arc is just a part of that circumference. So this red part would be considered an arc. Okay? How do we measure an arc? Well, if you got a central angle, it's really actually pretty easy. Much easier than the other ones we're going to learn about later. So let's say this is 100 degrees. The central angle is 100 degrees. Well, the arc that is created by the central angle, right here, would have the same kind of measure, 100 degrees. All right? Well, let's go back. So there are three different types of arcs. And first of all, you should probably learn how to name some. So let's call this AB. Okay, so arc AB has a measure of 100 degrees. So how do we name the arc? You should write down that this is how you name an arc. You name it by its endpoints of the arc, and you put an arc symbol on it like that. There's a little curve above it. This is called arc AB. Now, what if I didn't want to talk about this arc and I want to talk about this other arc that's all the way around this way? Okay, I'm going to try to highlight that in a different color if I can trace it somewhat decently. Okay, so this green arc is the one I want to focus on. I don't want to focus on the red arc. How can I name the green one? Well, they both have endpoints of A and B, so what can I do to distinguish this smaller red one from the bigger green one? I can't just call it AB because I won't know the difference between the two. So what we do is we'll have a third letter on here. It doesn't really matter where it is, just somewhere in that green area. And I'm going to name it C in this case. And this arc could start at A and go through C and end up with B. So this is arc ACB. Okay? The difference between these two things is this one is called a minor arc. A minor arc is one of the first of the three types of arcs. A minor arc, sorry for that sloppiness. Let me try that again. A minor arc is the first of three different types of arcs. This is when you have a measurement that is less than 100 degrees. I'm sorry, 180 degrees, less than half a circle. Okay? If you've got a major arc, it's going to be greater than half the circle. So a major arc is greater than a half circle or 180 degrees. So that's two of the three types. And so if you got one that's less than 180 and one that's greater than 180, maybe you're thinking, okay, the last one, it's got to be equal to 180, which you would be right. So when it's equal to 180 degrees, we call this one a semicircle. So I'm running out of space here, but we're going to say semicircle. Okay, and that would be like if I connected this radius with this one, and now I've got a diameter, and I'm going to call this D right here. So now this black one right here, it goes around this way. That is a semicircle. It's a half circle. Now, how do you name a semicircle? Usually we name it with 3 points, and I imagine you can get away with 2 because it doesn't matter if you're going DAB or if you're going DCB. Okay, they're both the same measurement. And maybe the only reason why they have 3 letters is so we know if we're talking about the top semicircle or if we're talking about the bottom semicircle. Okay, but typically you'll see it named with 3 letters. Now let me emphasize something else here. If you got arc DAB, that is the same name as arc BAD. It's the same thing. As long as it starts with one of those points, goes through the middle one, and it ends up at the other. Okay, arc DAB and BAD would be the same thing. Same thing here. Arc ACB and BCA are the same green arc in this picture. And then this one with 2 letters, I can name an arc AB or arc BA. It really doesn't matter. All right, so those are the 3 types of arc: a minor arc, a major arc, or a semicircle, which is just half a circle. Okay, so what if we want to find the arc length? So far we talked about arc measure, but now let's say we want to talk about arc length. Arc length is when we're actually going to figure out how long is that arc. Not as degrees, but how many feet, inches, miles, meters, whatever it is. How long is it? So let's call this one AB again. And I want to figure out the length of this. Actually, you know what? I'm going to make this a little bit different. What if I change this to a 90 degree? So I'm going to try to make that a nice right angle. Okay, so that's a nice right angle. Help emphasize a point here. Okay, let's say this was 10 inches as your radius. That means if I want you to figure out the whole circumference, you could probably do that. Circumference is pi times d. The diameter is not 10, that's just the radius. So the diameter is 20. So pi times 20. And typically we switch the orders. It's 20 pi and it's in inches. 20 pi inches. Okay. Now you might see that this circumference, if this is 90 degrees, this one's 90 degrees. And that means the circumference is a fourth. This purple one here is a fourth of the entire thing. It takes 4 90s to get through all the way around. So instead of 20 pi, I want a fourth of 20 pi. And in math, typically of, not always, but typically of is multiplication. So I'm going to take a fourth times 20 pi. If you know how to multiply fractions and whole numbers, you just end up multiplying straight across. Put this over 1, multiply straight across, you get 20 over 4. Put pi there. Which means the answer is going to be 5 pi. Okay? So that length is 5 pi. Now I can actually go ahead and multiply 5 times pi and figure out what that length is as a decimal. But the important fact is you understand that this is a fourth of the entire circumference. Okay? Now what if I didn't know it was a nice fraction like 90? 90 is really easy because we should be able to look at that and tell it's a fourth. What if it was like 89? It doesn't simplify, or 76, or 24, or whatever it is. Well, that comes from knowing that it's a portion of the whole circle. 90 over 360 simplified to be a fourth. That's how it's a fourth. Now, what if it wasn't a nice number like 90? Like I said, it could be some other weird amount. So I'm just going to clear this out just to give you an example. You don't have to recopy the whole thing. But let's say it was like, I don't know, this is 26 degrees. Okay, this is 10 inches. So 26 out of a total of 360 is what I'm looking for. This fraction, this arc is a fraction, a small piece of the entire circumference. So this fraction of the circumference, which once again is pi times diameter. Okay, so in this particular instance, it would be 26 over 360 times pi times diameter of 10. And you multiply all this stuff together and you'd end up getting the arc length. Okay, so length. So basically, what I would like you to take away from this, hope I'm not being too complicated, is that there's a formula here. Whatever the degrees are over 360, that's going to be your fraction, your piece of the circumference. And of, once again, is just multiply. So your basic formula is going to be the number of degrees of the arc, the number of degrees of this arc right here, out of what's possible, which is 360 from a circle, and then you're going to times it by the circumference of that circle. So you'd have to figure out what that is. Okay, so this is the important thing you need to know. This is how you come up with arc length. Okay. All right, what else? Now, the last thing I want to end this on is a clarification between the difference between arc measure and arc length. This is a big point of confusion, so I'm going to draw for you a picture here. Let's say we got 3 circles right there, and I'm going to go back to 90 degrees. So I'm going to draw 90 degrees. Now, hopefully you understand, based on what we just talked about, that what is the measure of, let's start with this small arc right here. What's the measure? Measures in degrees. It's the same as the central angle, so its measure is going to be 90 degrees right here. Okay, well, I got another bigger arc right here, but its measure is the same as the central angle, which is also 90 degrees. And I got the biggest arc right here, and its measure is the same as the central angle, which is also 90 degrees. Okay, so all 3 of these share the same measure of 90 degrees. However, hopefully you recognize the lengths are different. This blue length is longer, the green length is medium, and then the red length is the smallest one. So lengths are different than measures. Lengths are, think about the length as something you can measure in inches, feet, yards, meters, whatever it is. And so that could change, that would be a size, but the measure is a portion of the circle. Okay, so this is all, each one of these have 90 degrees. It's a fourth of their circle, but the measures are different. So hopefully that helps to emphasize the point. All right. Well, good luck. That's all the lesson.